my friends, and welcome to another episode of Your Math Class featuring your favorite math teacher, Miss Kate. And today we're going to talk about another new shape. So we've done 3 shapes this week. We've done squares, triangles, and today we're going to talk about parallellograms. Try saying that 8 times fast. Parallellograms, 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 you get what I'm saying. It's kind of a tricky word to say. So a parallelogram is a similar shape to a rectangle, but its internal angles are not 90 degrees. So you can see it's kind of like a square that's been squished at the corner to sort of make obtuse and acute angles in it. You'll notice that the length of a parallelogram does not start from back here. It starts at the very tip of the bottom of the parallelogram. Another important thing to note about a parallelogram is the height is not from here to here, because that's not a perfect vertical line. The height is from the bottom, its base, to its top, not the line. The line ends up being a lot longer. All right? Now you will notice with the blue lines that I put in, it makes it kind of look like 2 triangles. All right, and if you were to add another dotted blue line right here, you would see that it was 2 similar triangles and 2 similar triangles. Now the 2 triangles make a parallelogram. It's a pretty easy formula. It's just like the square and rectangle formula, where area equals length times height. So the length on the bottom, not the length all the way out to where it actually becomes a 90-degree angle, but the length on the bottom, which is 7 centimeters, and the height again is not on an angle. It has to be perfectly vertical. So it's from the top to the bottom. So we know that the length of this first object is 7 centimeters. So area is going to equal to 7 multiplied by 4. Piece of cake. So we know that our answer is 28. Make sure you check your units, which are centimeters. 28 centimeters squared. We include that square because we're calculating surface area. All right, we've got one more question here. And again, our arrows are showing us that it's 12 units from the top to the bottom, not this way. Another thing I wanted you to notice were the different sort of symbols that I used along the edges this time. All you really need to know about those symbols is that they have to match on either side to know if the side is the same length as or height as the other side. That's what that tells us. Sometimes they might be circles. Basically what those symbols along the line tell us is this side is the same as this side, so that we don't have to write 4 centimeters on this side and 4 centimeters on this side and 7 centimeters and 7 on this side. It just gets boring. It's no fun. So we created those symbols, me and all the mathematicians that invented math, just kidding. Those symbols were created so that you could identify which sides were all the same. And that's really going to help you when we start on Monday with composite shapes. All right, let's look at this one. So we see this one, it's got a double line on this side and a double line on this side. So I know that this side is equal to the length on the bottom is equal to the length on the top. And this line are the same. So I know that the height on this side is equal to the height on that side. So I know that it's 8 units by 12 units. It doesn't say centimeters. It doesn't say millimeters. Sometimes we just measure things in units. So I know that my area, the formula is length times height. And my length on the bottom is 8 units. And my height is 12 units. So I know that 8 times 12 is 96. I know that it's in units, so I just write the word units here. And I got to put that square. So again, it's just like a square, except it's a square that's kind of been squished and they no longer have 90-degree angles. And again, just like a rectangle or a square, you're going to see those 2 triangles in it. Now, you might see a question in your workbook that's going to talk a little bit about what would be the area of a parallelogram with these 2 triangles. Well, you're going to have to do some problem solving on your own. I'm going to see if you can figure that out. If a parallelogram is equal to 2 triangles and they want to know what would be the total area of this triangle or this parallelogram with these 2 triangles, use some problem solving skills. I want to see what you can do. All right, that's the end of your math lesson today, ladies and gentlemen. Thanks so much for tuning in.
Oh, sorry guys, I don't know why I can't ever get it right to make sure that I show you, zoomed in on the question, all the units, there you go, and that I don't cut off that 96. All right, have a great day, bye.